We're going to go over these problems. Do you understand and do you know how? Those are the problems that you were supposed to do for homework last night.
Senior males can now come to the gym with $10 to take their physicals. Senior males can now come to the gym with $10 to take their physicals and also bring a pen.
I'm going to do this to give us a little bit more room on here. Alright. So, this is on page, let me find it, page 12 of your student companion there. First problem says, how do you model a situation in which a function behaves differently over the different parts of its domain? So that's basically what we've been talking about all week, is we've been modeling these type of functions or these type of situations where different functions behave differently over certain parts of domains. So what I wrote is I said model each domain separately. So what we did, guys, remember we took each part and we looked at it as its own, correct? So we looked at them all separately. And then combine into one function. Using a brace. What is a brace, guys? That's just like right here. Do you see how they combined it into one function down here? They did that using a brace. All right, number 2 says, how do piecewise defined functions differ from step functions? So if we go back and, looks like I've erased everything. Maybe not. This is one of our piecewise functions, remember? And then we could talk about these guitar strings as being one of those step functions. So, what I wrote down for number 2 was, describing the difference. Piecewise functions are two or more functions over different intervals. And step functions are two or more constant values, because remember we talked yesterday about it being a straight line because you could only cost you one price to be in that parking lot. So step functions are two or more constant values. Number 3 says, given the function f of x is equal to 2x plus 5, and our domain is negative 2 is less than x, which is less than or equal to 4, and the function negative 4x minus 7 with the domain of 4 is less than x, which is less than or equal to 9. Rebecca says there should be an open circle at x equals negative 4. Or not x equals negative 4, x equals 4. For both pieces of the function. Explain her error. Well, look, right here I could see where she would think that it was an open circle because there's not a line underneath it, right? What about right here? What kind of circle is that telling us? What does that symbol right there tell us? It should be a what type of circle? Closed circle. So for number 3, I said for the first domain, x equals 4 should be a closed circle. Number 4, what steps do you follow when graphing a piecewise defined function? So this is where we took it one step at a time. So all right, take it one section, take it one section at a time, following the domain. We got to make sure we follow the correct domain. Remember, your domain are these restrictions like here and here, okay? So after we take it one section at a time following our domain, we need to make, so then I said making note about whether circles need to be open or closed. And then the last question here on the left side, it said, is the relation defined by the following piecewise rule a function explain, and they want us to explain it. So that's when, and they didn't give us a graph, they didn't give us an opportunity to even graph it or anything. So I'm going to bring up your graph here. So we have y is equal to 7x minus 4. And then our restrictions are x has to be less than 2. Oops, not that. And then our second equation was negative x plus 5. Forgot my y equals. And our restrictions for this one are x has to be less than or equal to 2. Close our brackets. So if I look at this equation here, let me zoom out. What I would do is I would say, oh, did I do it right? Oh, this should be negative 2, not 2. Okay. So remember, this is our piecewise function. Do you guys remember, probably back from Algebra 1, where you had to follow the vertical line test to see if it was a function or not? So if you were using the vertical line test, would this piecewise defined function, would it pass that rule? Not at all, because look, right here, it has more than one x value, right? Or more than one y value for these x values. So that's why it would not pass our vertical line test. So since it does not pass that vertical line test, we're going to write no because from negative 2 to 2, there are 2 outputs for every input. Everybody got that? Alright, so then they told us to graph the function of each of these. They didn't give me any graphs on this, so let me go back and grab one actually. So our graph should have looked like, so if we're looking at number 6 here,
All students still needing physicals can now come to the gym with $10 to take physicals. All students who have not done a physical today can now come to the gym with $10 and please bring a pen.
alright, so I'm going to graph the first one in red. So remember, we are only paying attention to the two ending points. So if I've got f of x equals negative x plus 1, I'm going to plug in negative 10, and I'm going to plug in negative 3. I'm doing this in order to get my starting and stopping points, or starting and ending points. So that would be when x is negative 10, y is 11. When x is negative 3, y is not 5, but 4. At negative 10, should I have a closed circle or open? Closed. What about at negative 3? Open. So if I just do normal size graphs here, let's see what we can figure out. Draw it down the middle. I'll draw this one down the middle. So at negative 10, if I go 1, 2, 3, 4, 5, even if I go over, I guess I could go by 2s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. We could go up 1 just a little bit to make it 11. And it should be a closed circle. Then if this is negative 2, I guess we could have labeled. I could have labeled negative 2, negative 6, negative 10, just so it's not taking up too much room. Do the same here. 2, 6, 10, negative 2, oops, negative 2, negative 6, negative 10. Alright, so I've got a point at negative 10, 11, and a point at negative 3, 4 that has an open circle. Connect those two dots, and there's the first part of my piecewise function. Next part, I'm going to graph here in blue. Starting points are at negative 3, and stopping point is at positive 3. It is quadratic, though. Because it is quadratic, tells me it's what type of graph. It's not going to be linear, but it's going to be, starts with a Q. Any idea? It's going to be quadratic. So if it's quadratic, that means I have a vertex. I can look at this equation. Do I have an h value? Do I have anything inside parentheses anywhere? Is there a parentheses anywhere right here? No. The last number is your k value. So our vertex is at 0, negative 9. So now I'll plug in negative 3. And I'll also plug in positive 3. So when negative 3 is our x value, 0 is my y value. When positive 3 is my x value, 0 is also my y value. I've got a closed circle and closed circle for both of these, so I'll find negative 3, 0, closed circle, negative, or 0, negative 9 in a closed circle, and then 3, 0 with a closed circle. Alright, and then my last graph here, it's 2x plus 1, so that's linear. So f of x equals 2x plus 1. Plug in 3, so 2 times 3 plus 1 would give us 7 when x is equal to 3. And then when we plug in 5, 2 times 5 plus 1, when 5 is our x value, 11 is our y value, and they are both open circles. So at 3, 7, 1, 2, 6, 7, and then at 5, 11. Any questions about graphing that piecewise function? Everybody got it? Alright, so now we have to graph the second one. And I'm going to change it so that my axes are on the side here. Something like this. Somebody open the door for us, please. Thank you. Alright, so 7 is actually pretty easy because I've just got y is equal to 1, or g of x is equal to 1 between 0 and 2. So we're actually going to go up by, we're just going to go up by 1s on each of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll do the same for all of these. So this tells me that y is equal to 1. 0 is a closed circle, but 2 is going to be an open circle. So it would look like this. And then we say y is equal to 3 between 2 and 4. So we go up to 3, and 2 is a closed circle, but 4 is a what type of circle? Open. Y is equal to 5 between 4 and 6. And y is equal to 7 between 6 and 8. So the first one we did on 6 was a piecewise function. The second one would be what we consider that step function because it's more of a constant rate. Any questions about number 7? Alright, if not, let's take a look at 8. 8 gives us this piecewise function. It says, is the function decreasing or increasing over the interval 2, 7? So the interval 2, 7 is in between somewhere right here because it's between 0 and 8, right? So we are going to be focusing right now on just this equation, negative 2x plus 4. Is the function increasing or decreasing over that interval? And then find the rate of change over that said interval. Remember, rate of change is the same as the slope. Can somebody look at this equation and tell me what the slope of this function is? 2. The slope is 2, or not 2, but it is, it's 2, but what's in front of the 2? Negative. So the slope is negative 2. So if the slope is a negative number, is it increasing or decreasing? Decreasing. So for 8, I wrote decreasing, and what's the rate of change? Negative 2. All right, and then number 9. What is the rule that defines the function shown on the graph? Remember, that's where we took all of our your sections and we put them in that stat edit and we tried to figure out what the equation is. But this one, we're going to make it just a little bit easier on ourselves. We're going to start with this first section. What does y equal right here? 1, 2, what? 3, right? So we're going to have, I know we're going to have 3 different things, so I'm going to make this a little kind of big. So we know y is equal to 3 because it's that straight line. And where do we start? What is our x value that we start at y is equal to 3? At negative 2. And do I have since it's an open circle, do I have a line underneath my interval? No. Negative 2 is less than x, which is less than, stops right here, and it's a closed circle, so that would be less than or equal to 0. We'll do the same thing for the next 2. What's my y value right here on the second section? 0.5. And if it's 0.5, that means that we start at 0. 0 has an open circle, and we stop our x values at 2. Yep. And then our last one here, y is equal to negative 2. We pick up at positive 2 with an open circle, and we stop at positive 4 with a closed circle. Because my online textbook is down, you will need to get out your textbook kind of follow along today for some of these examples. And it starts on page, it's like 40 something. Yeah, or 31. And we're going to go to page 39 or 37. So 31 to 37 is what we'll be looking at today in your textbook. Most of you, Lucas, if you want to move to a different seat so you can put your book in front, if you don't have enough room again, okay? That's why I turned these desks around so that you could have enough room for your book and your companion as well. 30. Should say 1-4 at the top. All right, so today we're taking a look at arithmetic sequences and series. I know, again, you've seen this in algebra. 1, at least some of it. I know that's been a while for some of you, though, so we're going to just kind of review what's going on here. So, Umiko, I guess, and Hugo are looking at the table of data. Umiko writes f of 1 is equal to 1 plus 4, which is equal to 5. F of 2 equals f of 1 plus 4, which is 5 plus 4, so that equals 9. So he's taken each individual step and adding it to the other. Do y'all see that? He's taken each step, kind of adding it together to get his table figured out. Hugo just writes g of x is equal to 1 plus 4x. Describe the pattern Umiko found for finding an output value for A. So, what was Umiko doing? He was adding what to each number? 4. He was adding 4 more than the previous number. So each output is what I wrote. Each output was 4 more than the previous number. So all he was doing, see, this is on page 13 in that companion. All he was doing was adding 4 more to the previous number. B says describe the pattern Hugo found for finding an output value. Well, he came up with a formula, right? So I just said he used a formula to calculate the next number, because he came up with the formula of 1 plus 4x. C says compare the two methods. Is there anything wrong with either method? No, they're both right, aren't they? But which method would be more useful for finding the 100th number in the list? Hugo's number, or Hugo's method. Because you could just plug 100 into the formula, right? For Umiko's method, you would have to find the first 99 before you found that 100th number, right? So for C, I wrote Hugo's method would be more useful.
Any teachers needing a DOT physical, you can come to the gym right now. Any teachers needing a DOT physical, you may come to the gym right now.
Hugo's method would be more useful because you could just plug 100 in the formula. For Umiko's method, you would have to find the first 99. Everybody got A, B, and C? All right, next it says find the average rate of change between a few pairs of points. What can you conclude about the function represented in this table? Average rate of change, what were we changing by in each output? What were we going up by? 4. So the average rate of change is 4. So since the average rate of change is 4 between each function, that means that this is, or between each value, that means that these values are probably a linear function because our rate of change stays consistent. All right, so this next part is still on page 31. It says, is the sequence arithmetic? If so, what is the common difference and what would the next term be in our sequence? So we've got this table of one that they've given to us. It says this is a sequence, a function whose domain is the natural numbers. Create a table that shows the term or domain and the term or the range. So I know you've got that extra space, right? I'm going to use that extra space for us today for you to write these examples because I think these will be good for you to have in your notes to be able to look back on if you ever have some questions. So in that extra space, guys, I want you to draw out this table that is on this page, okay? So I drew my table out. Got an X and a Y, and I'm just plugging in these 6. 1, 2, 3, 4, 5, 6. We've got 3, 8, 13, 18, 23, and we need to figure out that next term. So we've created our table. Then it says an arithmetic sequence is a sequence with a constant difference between consecutive terms. This is known as a common difference, or D. So let's look at our terms. How do we go from 3 to 8? What are they doing? They're adding 5. From 8 to 13, they're adding 5. They keep adding 5, right? So I even drew me some errors like that table has so that I see that we're adding 5 to each term. The difference between the consecutive numbers in the range is 5, so that's our common difference. This sequence is an arithmetic sequence with a common difference of 5, so that means D equals 5. So the next term in our sequence would be, so hold on, let's write this out. So yes, it is arithmetic. Common difference. D equals 5. So that means to get the sixth term, we would say 23 plus 5 and add that together to get 28. Is everybody cool with that arithmetic sequence? All right, so as example 1 is continued on our next page. So we would turn the page to page 32. And this asks us, how could we write a formula for finding the next term in the sequence? They've come up with this whole big way to write the formula, but this is what we refer to as a recursive definition. Above example 1, above where it says try it in your notes, I want you to write the recursive definition. So I wasn't going to read through all that. I'm just going to tell you what this formula is, okay? So the recursive definition. So this is our way to write our formula so that we can find our next term in our sequence. Our recursive definition is going to be A sub n is equal to, and it's going to be two different things. We're going to have a sub 1, where n equals 1, so that's going to be our first term. And then we have a sub n minus 1 plus d, which is our common difference, as long as n is greater than 1. I know that looks like a bunch of jumble to you right now, but when we plug it in for our next equations, it will hopefully make sense for you. Everybody got that? Can I move on? So the try-its say, are the following sequences arithmetic? If so, what is the recursive definition and what is the next term in the sequence? So let's see. How do we go from 25 to 20? Subtract 5. Are we subtracting 5 to get from 20 to 15? Yes, and also from 15 to 10 we subtract 5. So is it arithmetic? Yes, it is. And if it's arithmetic, guys, what is our common difference? What does D equal in this case? What are we doing each time? Minus 5, right? So negative 5. So I'm going to take that information and just plug it, really I'm just taking that D value and plugging it into that bottom equation there, okay? Because they want to know the recursive definition for this. So I would write a sub n minus 1 minus 5. That's our recursive definition. And then it says, what would our next term in the sequence be? What would be after 10? 5. All right, our next sequence, we've got 2, 4, 7, 12, and 13. How do I go from 2 to 4? Add 2. Am I adding 2 to go from 4 to 7? No, that's plus 3. The next one would be plus 5 and then plus 1. So is this an arithmetic sequence? No. It is not arithmetic. All right, example 2 has all this big written out definition of something, and it says an explicit definition, and it tells you what the explicit definition is. Guys, that's the only thing that I am concerned about from this part right here. I want you to write this out to the side. If you can't see it, it is there on your paper on page 33. I want you to write this formula out to the side. Well, so that we know, and you can even write that it's an explicit definition, because we will be referring back to this quite often today. Write this in the margin of your notebook. Does everybody have that? All right. I want us to make note real quick, guys, that on part B right here, it gave us the explicit definition. We had A1, we had D, and we had N right here. So A sub 1 came from right here, 16, A sub 1. The common difference came from in front of the parentheses, and that's negative 3. So they were able then to rewrite the recursive definitions because we're going to have to do that here shortly. So for 2a here, we're given the recursive definition. It says a sub n is equal to, and it gives us 45 when n is equal to 1. A sub n minus 1 minus 2 when n is greater than 1. What is the explicit definition? So for a, I know that the explicit definition should be a sub n is equal to a sub 1 plus d times n minus 1. Well, if I'm looking at that recursive definition up here, can anybody tell me what a sub 1 equals? That's the first number they give you right here. A sub 1 is equal to 45. In that second equation, can anybody tell me what that common difference might be? There's only one number in there. In the second column, or in the second, -2. So our common difference is -2. So now we have everything that we need to plug into to write it as an explicit definition. So we would write it as a sub n is equal to, we got a sub 1, which is 45. We got our common difference, so we're not going to write plus, but instead we're going to write minus 2 times n minus 1. So now we're going to work backwards for b. We're given that explicit definition, and they want us to rewrite it as the recursive definition. So to rewrite it as the recursive definition, we have to first identify what is our a sub 1 and what's our common difference. So what would, in this equation right here, what would a sub 1 equal? 1. And what would our common difference be, or what would d equal? 7. And guys, we just plug it into this for our recursive definition. So we would write a sub n equals a sub n minus 1 plus 7 when n was greater than 1. And then I'm going to say that 1 and comma n equals 1. And that's our recursive definition. So we took recursive, put it in explicit, then we took explicit and put it in recursive. So we just did the opposite. Now on example 3, to actually kind of start putting these into play. It says a high school auditorium has 18 seats in the first row and 26 seats in the fifth row. The number of seats in each row forms an arithmetic sequence. What does the explicit definition, or what is the explicit definition for the sequence? The problem states that A1 is 18. So out in your margin, that's where I'm going to write I'm actually going to write it over here so that you kind of have an idea of what side it's on. All right, so for A sub 1, it states that that is 18 because it says in the first row we've got 18 seats in our auditorium. And 26 seats in the fifth row. So if it's 26 seats in the fifth row, A sub 5 should be 26. It says that the problem also states that n equals 5. How do we know that? Because that is how many rows we have, the number of rows. So n equals 5 because that was A sub n. That was our last row. So the first row has 18, the last row has 26. So A sub 1 is equal to 18, n is 5, and the fifth row has 26, so A sub 5 is equal to 26. So for A, what is the explicit definition? Well, this is where that comes back in handy. A sub n is equal to A1 plus D times n minus 1. We are trying to write our explicit definition, but we can't write our explicit definition without the common difference. So that is what we are about to have to solve for. So we got a sub n, that is 26, because it has 5 rows. So I plug 26 in for a sub n. I'm going to plug 18 in for a sub 1, and then 5 in. I'm going to plug 5 in for n. So 18 plus d times 5 minus 1. And then I'm going to simplify and solve for d. So 26 equals 18. 5 minus 1 is 4, so 18 plus 4d. How would I start to solve for d, to get d by itself? Any clue? Do what? Well, that would be our next step, but how would I get rid of this 18 first? Subtract 18. So 26 minus 18 is 8. 8 is equal to 4d. So that means 2 is equal to d, right? So what does that actually tell us? Well, that tells us that each row has two more seats than the previous row. So each row has 2 more seats than the previous. So now that we know what D is, guys, we can write our explicit definition up here. Explicit definition is going to be, and I'm just going to label it as ED, that's just a little bit easier for me. A sub n is equal to 18 plus 2 times n minus 1. That explicit definition would allow us to figure out how many are on row 2, 3, 4, since we already know what's on 1 and 5. All right, B, this is continued. B says how many seats are on the 12th row? If we were to go up to 12 rows, how would we figure out how many seats were on the 12th row? Well, we would take that explicit definition that you just wrote. So for B, I wrote 12th row so that I knew what I was talking about. I would take that explicit definition that we just wrote, and I would say A sub 12 is equal to our starting point plus our common difference, n, A sub n, so that means n is equal to 12 minus 1, and you would just solve for what was on the 12th row. You put this straight in your calculator as it looks. You would put this straight in your calculator as it looks, and you would get that there were 40. So that means there are 40 seats on that 12th row. All right, now we're going to try these try-its and see what we can come up with. So Samantha is training for a race. The distances of her training runs form an arithmetic sequence. She runs 1 mile on the first day and 2 miles on the 7th day. What is the explicit definition for this sequence? So the first thing I notice is that the 7th day, A7, is going to equal 2, right? A7 equals 2 and A1 equals 1. Because on the first day she runs 1 mile and on the 7th day she runs 2 miles. So we have to figure out what the explicit definition for Samantha is. So what we have to do first is we have to plug in, excuse me. Hold on. I'm trying to make it where I can write under this. That way it's a little bit easier for us to kind of look at together. Ooh. Hold on. Sorry, guys. Just give me just a second. Here we go. That's what I was looking for. All right, what's the explicit definition for this sequence? So what I did was I came over here and I know that A7 is equal to 2, A1 is equal to 1. We do not know what D is. N is equal to 7 minus 1. If you want to write N equals 7, you can do that as well up here. Because before we write an explicit definition, we have to figure out what our common difference is between each day, how much more she's adding to her run each day. So I do this to solve for D. So I now have 1 plus 6D, because 7 minus 1 gave us 6. Subtract 1 from both sides. So 1 is equal to 6D. Divide both sides by 6, and I get 1 over 6 is equal to D. So that means our common difference is 1 over 6. So that means she's adding 1/6 of a mile to her run daily. So my explicit definition would be written as A sub n is equal to your first term, which is 1, plus your common difference times n minus 1. So that's our explicit definition for that sequence. Well, now I need to figure out how much she's going to run on day 19. Well, instead of day 7, instead of plugging 7 in for n, what am I going to plug in for n now? 19. So 19 is going to equal 1, or not 19, but A sub 19, because that's the 19th day. So 1 plus 1 over 6 times 19 minus 1. At this point is where you would plug this into your calculator. What do we get? How much does she run on that 19th day? Four miles. 4. So that means on the 19th day she runs 4 miles. How can you use the recursive definition for an arithmetic sequence to find the 120th term? We could rewrite the recursive definition as an explicit definition. Then use the explicit to calculate A sub 120. All right, next part, finding the sum of an arithmetic series. It says, what is the sum of the terms in the arithmetic sequence 1, 4, 7, 10, and 13? A finite series is the sum of terms in a finite sequence. A finite arithmetic series is the sum of the terms in an arithmetic sequence. For the sum of n numbers in a sequence, you can use a recursive formula or simply add the terms together. They give you this big long thing, and the only thing that I truly need you to know out of this first step is to the left of this paper. I want you to in the margin up here where it says example 4, I want you to write Sn equals n times a sub 1 plus a sub n. So that's your first term and your last term divided by 2. N is how many terms you have. So a sub 1 is going to be your first term, a sub n is going to be your last term, and you divide it by 2. That tells you what the sum of all the numbers are. Did y'all write that in the margin for me? Okay. So part B, I want you to ask us what is the sum of the following arithmetic series. So what we are going to do is we are going to use that formula S sub n, which, hold on, I know you've already got it written, so I'm going to rewrite it up here so we can refer back to it. Y'all should already have it written. What is the sum of the following arithmetic sequence? We've got 2, 6, 10, 14, 18, 22. Sure, you could add those all up on your calculator and you would get the right answer, but this formula allows you not to have to do that. So the first thing we want to figure out is how many terms do we have? So what does n equal? So, and I actually wrote these out on my paper as I was working out the example, just so I know if I'm looking back at it, what all we put there. First thing I want to know is how many terms do I have? I've got 1, 2, 3, 4, 5, 6 terms, correct? What's my first term? A sub 1. 2. My second term is, not my second term, my last term is 22. We're going to take n, a sub 1, and a sub 6 and plug it into my formula up there. So the sum of these 6 numbers should be 6 times 2 plus 22 divided by 2. You can put the top part in your calculator and then divide it by 2. You can put it all in the calculator as one big thing. And what do we get as the sum of all 6 of these numbers? 72 is correct. All right, so the n is how many you have. So 1, 2, 3, 4, 5, 6. The 1 means your first term. And then, this will change. Let's say we had 7, this will be a sub 7, okay? Because it's just whatever your last term is. So our last term was the 6th number, right? So that's where we got the 22 from. So let's look at the next two. Oh. Looks like I skipped them, doesn't it? My textbook isn't working. Well, hold on. Let's see what we can do. We'll just write them out, okay? So for 4A, it tells us that we've got 12 terms, right? Are y'all seeing that in 4A? Find the sum of each arithmetic series. A is a series with 12 terms. And it tells us a sub 1 is equal to 3. And a sub 12 is equal to 25. So we are plugging it into this formula. S sub n is equal to n times a1 plus an over 2. So total we have is 12 terms. So if we're plugging this in as a sum, n is going to be what? Equal to what? 12, because that's how many we have. Our first number is what? 3, and our last number is 25. Divide all of that by 2. One what? 168 is correct. 4b, this time it doesn't tell us anything. It just gives us 5 plus 11 plus 17 plus 23 plus 29 plus 35 plus 41. So on our own, we have to decide how many terms we have. 1, 2, 3, 4, 5, 6, 7. You're correct. So n equals 7. What is my first term? 5. And a sub 7 is 41. So we'd plug it in that formula. Sen is equal to 7 times 5 plus 41 divided by 2. 161. All right, so this is concept of sigma notation. It says the sum of n terms of a sequence can be written using sigma notation. The index I counts through the terms in a partial sum. Here it takes the values from 1 up to n, the last term in the partial series. The value of the ith term is a sub I. You can use the explicit formula for the sequence in place of a sub I. It's a lot of information to just kind of show you this. It says, what is the sum of 2i minus 6? So what we do over here, instead of doing all this work that they plugged in 1, 2, 3, 4, 5, 6, 7, 8, 9, and then added that all together. That seems to be like a lot of work, right? So I'm going to come over here and I am going to hold on. Hey, that worked pretty good. All right, I'm going to just write the sigma notation, the summation over here. We've got this E. Oops. It says 9, so that means there's 9 total terms, and our first term is 1. And it even tells us that our equation is 2i minus 6. So they said that we could use the explicit formula to figure out what our sum was. So in order for us to use our explicit formula, well, no, that's when we're doing something else. That's when we're writing the series of the sigma notation. All we need here to find the sum, because that's what we're looking for, is we need the first term, the number of terms, and the last term, which that can be pretty easy to find. So the first term, a sub 1, we just plug 1 in for I. So 2 times 1 minus 6. To find my last term, the number on top of the E, the number on top of the sigma, tells me my last term. So there's only 9 terms, so that means that 2 times 9 minus 6 is going to be my last term. So what is your first term equal to? Negative 4. My last term is equal to 12, right? All right, now we're just going to use that summation formula, this one in red that we wrote. We're going to use it to figure out the sum of all our terms. So how many terms total do we have? 9 times our first plus our last divided by 2. That should be a plus sign, by the way. $36 is correct. All right, so that's for part A. I want you to kind of draw a squiggly line under this for part B because it is a little bit longer. And it says, how can you write the series 2 plus 9 plus 16 plus ... plus 79 using sigma notation. And then they want to know what the sum is. Well, that takes us back to this information right here, or over here. Right here, actually. Because we don't know how many, or we don't know what the difference is, so we don't know what they're going up by each time, and we definitely don't know where it stops. So I have to first find my common difference in order for me to write my equation. I have to find my common difference. So that's why, and I even had to go down under example 6 for this one because it is kind of a lot. But I've got 2. All right, what they've given us is we've got 2 plus 9 plus 16 plus dot, dot, dot. We don't know what all those numbers are or how many are in those dots, plus 79. They want us to write the series using sigma notation, and then they also want us to figure out what the sum of that is. Well, in order for us to figure out that sum, we have to figure out how many terms there are. So what we are about to do is we are about to figure out our common difference, our first term, and our last term, plug it into our explicit definition, and then we'll be able to solve from there. So how do I go from 2 to 9? Plus 7, 9 to 16, plus 7, right? So that means that my common difference, or my D value, is equal to 7. What's my first term? 2. I'm saying A sub n because I don't know what number 79 is, right? I don't know what term that is. So A sub n is 79. So this goes back to that recursive formula, so I'm going to rewrite it, which was A sub n is equal to A sub 1 plus D times n minus 1. And this is where we are going to have to solve for n, because we don't know how many terms we have. That wasn't given to us. So we're going to plug the information that was given to us in. So I've got 79 is equal to 2 plus 7 times n minus 1. All right, what do you think I'm going to do now to solve for n? Distributes correct. 7n minus 7. Then we can combine like terms, right? So 79 is equal to 7n minus 5. And hey, I want you to keep a note of this right here, okay? Because we are going to come back to that. That's going to be our equation we use. And then on my paper, I kind of ran out of a little room, so I went up here, drew some line, and said 84 is equal to 7n, so that means 12 equals n. If 12 equals n, how many total terms do I have? 12 is correct. So to write it in using that sigma notation, I would say, oops, I'm going to write it in a different color. I would take my sigma notation. We have 12 total terms, right? I is going to equal 1 because we're starting with our first term. And then we're going to use this equation right here, 7n minus 5, except for we're going to change the n to an I minus 5. And just like we did on this problem right here, remember how we went in and used the summation formula? We're going to do the same thing. So we know how many terms we have. That's given to us. That's 12, right? My first term, A1, is 2, and my last term is 79. and then you divide everything by 2, and we figure out the sum of that series. What is it? 486, and that is correct. All right, number 5, A on the try it. We've got what is the sum of the series, and it tells us 13 where I equals 1, and then 3I plus 2, right? It says what is the sum of the series? So the first thing we have to do to figure out what the sum of the series is we have to know what n equals, we have to know what a sub 1 equals, and we have to know what a sub n equals. Well, what's n equal? How many terms do we have? 13 is right. Figure out our first term, we plug it in. 3 times 1 is 3 plus 2 is 5. A sub n is going to be a sub 13, right? Because we figured out what n was. 3 times 13 is 39, and 39 plus 2 is 41. Now we can use that summation formula where we take n, first term, last term, and divide it by 2. Do I get an answer? 299. All right, we'll do one more, and then we'll pick back up at 6 tomorrow, okay? So 5B. How can you write the series 8 plus 13 plus 18 plus dot 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 plus 43 using sigma notation, okay? And then they want us to figure out the sum. So before we can write using sigma notation, we have to know how many terms there are. Well, in order for us to know the terms, we got to figure out what n is. Huh? Okay. So, yes, we are adding 5, so that's a good thing to know. We know that D equals 5. Our first term is 8, right? And our last term is 43. Well, we still don't know what n equals. That's the big deal. That's what's holding us up from writing in that sigma notation form and figuring out what our sum is. So in order for us to figure out what n equals, we're going to plug it into our explicit definition. So 43 is equal to 8 plus 5 times n minus 1. And this is where we have to solve for n. We solve for n by distributing first. So 8 plus 5n minus 5. We then combine like terms. So 43 is equal to 5n minus 3, or plus 3, excuse me. 8 minus 5 is a positive 3. So we're going to know that we need to come back to this for our sigma notation. So 40 is equal to 5n. That means 8 equals n. So if 8 equals n, how many terms do we have? 8. So to write this in sigma notation so that we can figure out what our sum is, we write an 8 on the top. I equals 1. 5i plus 3, and there's our sigma notation. Now to find our sum of that sigma notation, we would say 8 times first term, oh not 8, do what? Yeah, that is right. Is it? No, it's how many, it's the number of our terms, n. That's why it's throwing me off. Alright, the number of our terms times our first term and our last term over 2. That's why it threw me off, because it was both 8. $204. You should be able to do all of the homework problems. Yeah. Maybe not 11, but I want you to at least try it, okay? And then we'll do 6 tomorrow and check the homework.